Hello everyone, my name is Barrett, and today I'm going to talk about marine sediment sustained accretion beneath the fluvial-tidal delta. And as a picture of the red circle is delta. So, before my presentation, I want to let you know what is TGD. The full name of TGD is Three Gorge Dam, and it is the largest hydropower station in the world, and is located in China. And here is the China map, and here is the location of TGD. And here's about the TGD picture. So, human interference has frequently affected the coastal area, and the reservoir congestion caused most of the world delta have now been significantly dammed in the upper and central reaches. So here is the picture about reservoir congestion, and here is upper reaches, and here is central reaches. Here is estuary. So, the research found out that there are other delta accretion has occurred despite the low sediment supply. So, they investigated one of the largest delta in the world, is Changjiang Delta. Here is the location of Changjiang Delta. And after TGD was built in 2003, the annual river suspended sediment supplies to the estuary declined by over 50%. Here is the picture about suspended sediment. All of the arrow represent suspended sediment. So, so although the TGD was built, the researcher has shown that both erosion and deposition has occurred in Changjiang estuary. So, they investigated the evolution of Eastern Chongming Shore, and I will refer at ECS in my presentation. Here is the entire of Changjiang Delta, and here is the location of ECS, and which is the most mature wetland in Changjiang estuary, and the most preferred place for sediment deposition. So this is the question that we want to explore. Even though the dam reduced the sediment in estuary, but why still some delta group has occurred? So let's go to the method and result. The researcher product a unique data set combining different morphological survey of the ECS from 1984 to 2030. The morphological means the place we investigated maybe for 1 year or 2 years. It is called the first morphological. And the same place we continue investigating maybe for 2 years or 3 years. It is called the second morphological. So the survey will conduct using low frequency echo sounder. This is a kind of sound wave device, and you will investigate the water deep. Here is the result of using low frequency echo sounder. Here is the ECS, and the red line represents the 2 deep meter of water, and the blue line represents the 0 deep meter of water. And theodolic and GPS device were used for survey in 1984 to 2030 with a position. Here's the picture about theodolic, and it can detect the latitude and longitude. And the Changjiang Water Resource Commission will provide yearly suspended sediment discharge. The Changjiang Water Resource Commission is a kind of China government institution, and the sediment discharge means sediment release, and suspend sediment concentration at Dadong Nature Station. Here is the location of Dadong Station. So, the researcher DB from Dadong to East China Sea. Here is East China Sea, and here is ECS. Here is Dadong. Into 16 stations, and each station have the same physical property. So you can see the picture. The yellow number is represent each station. This allows checking the amount of sediment delivered from each station to ECS. Okay, let's see the result. The color getting blue means the place was getting eroded, and the color getting red means the place was getting deposited. And picture A and picture B is before and after TGD was built. So we can see that the many places are getting eroded. But when we see picture C compared to picture D, the erosion part became into deposition part. And let's see picture D compared to picture C. There are more deposition part than picture C. And let's see picture E. Just only here getting eroded, but other places are getting deposition. And let's see picture F compared to picture E. Most of the places are getting deposited, but only here getting a little bit eroded. And picture G is from 1984 to 2030. And we can, as you see the picture, you can know that the deposition part is more than the erosion part. And picture H is the net volume change rate. You can see that only 1990 to 1997 was getting decreased, but others were getting increased. So the picture we can know that the area of deposition and erosion are indifferent in each picture. This mean is irregular. So let's see the next picture. The XEZ is for year and YEZ is for tidal area. And 1984 to 1997 is before and after TGD was built. And you can see that after TGD was built, the tidal area was getting decreased. But 1997 to 2018 was getting increased. So the picture we can know that the contraction of TGD is not completely related to the amount of sediment and area of delta. So let's see the next picture. SEZ is from Dadong to East China Sea, and YEZ is for sediment fractions. And the blue bar represents the concentration of suspended sediment after TGD was built, and yellow bar represents before the TGD was built. And the B picture is another form of picture A, and they represent the same things. But B picture shows that the suspended sediment accumulate nearly the estuary. So, although suspended sediment concentration are declined by conjunction of TGD, but amount of suspended sediment are mainly derived from area close to estuary. So, let's go to see the discussion. Because Changjiang Delta have longshore current of the river mouth. So, what is longshore current? Longshore current will cause the marine sediment deposit on the wetland. So, are relatively strong, and this can thus contribute to landward sediment transport. And many places with strong coastal current also have this situation. But other places which have microtidal regions. Microtidal regions mean the place have a weak wave or weak tidal or weak current, inhibiting faster land loss following the reduction of relevant sediment. So, marine sediment might be able to initially relieve the impact of decreasing sediment supplies, but continuous decline in fluvial sediment still can cause sediment starvation. Let's go to discuss the question we talked before. Because the area has strong longshore current, wave or tidal, and this will cause marine sediment accumulate in the delta, but this is only a temporary phenomenon. Thanks for listening.
Can you go back to the picture A to G, the slide?
Yep.
Yeah, is the picture of A to G is Changjiang?
Is ECS.
ECS.
It's here.
So,
Here.
So it is because the build of the TGD, three what the name of brief I forget.
TGD, right?
Yeah, it is because the build of TGD, so they will get eroded or stimulated. But I wanna know what's the reason that the erosion is getting stronger and the deposit is getting stronger too.
Repeat the question.
You say the erosion getting stronger and the erosion getting deposit.
Yeah, I want to know the reason why.
One more time.
Do you understand her question?
Half.
Repeat again your question.
Sorry. I want to know why the reason of the build of TGM will cause the stronger erodes and stimulated.
Oh,
Yeah.
you can see.
What's her
You
question?
want to know about TGD will cause the place erodes or deposition, right? So the picture A is before the TGD built, and the picture B is after the TGD built. And you can see that after the TGD was built, there was more getting erodes than picture A. Okay, but picture C is getting deposit because of the marine sediment.
Do the morphology of the delta change with the season?
Yes.
Repeat.
He say it's the morphology change at the season, right? Yes, but the method and result are.
Did you answer?
Yes, I don't know how to say the word.
Which word?
Order.
Neglect.
Oh. But the method and result are neglect the weather.
There is no TGD spots will happen to Changjiang Delta.
The river run sediment.
Repeat.
He said if there have no TGD, what will happen to the Changjiang Delta? The river run sediment will accumulate in the estuary.
Can you explain how longshore current cause the sediment deposit?
You want to know how long the longshore current causes the sediment deposit, right? The paper didn't have write about this, so I don't know.
His introduction is was very nicely prepared. So I noticed that he added a lot of images, and for every word that he thought might be strange or new to you, he added photos, images to support his presentation. So this is really nice. And I also like the way he presented this figure, because in this figure, but I think you can use pointer more often, right? So at the beginning he talked about what the colors represent, and then he went through this figure step by step, so it's very easy to follow his main point. But I think like one of the questions, you probably need to show us, because it's not easy for the audience to understand what's this place. You probably need to show first, like during your Q&A session. Remind us the place that you're talking about. I think you're talking about this place, and then remind us this place, and then show us these temporal changes. Okay, and then this one is also nice, but you didn't, considering that your talk was below 10 minutes, I think you can discuss this. This is also interesting because this is the discharge rate. That seems to suggest that the discharge rate was, I don't know, what you say, affected by the dam? I don't know. Okay, however, starting from this one, it's getting a little bit messy. So first, when you present this figure, I would suggest that you don't put these two together. You first put a map next to this place first, because it's not really clear for us. I think for those who haven't been, who are not very familiar with the geography of China, what's Datong? I don't know. Where is it? Actually, I have been in your research area. I know where you are talking about, but not for the audience here. So better to show a map here. And then the next thing is you presented, yes, that's the x-axis, y-axis, the yellow bar, green bar. But what's the meaning of this data? What's that? So you have to explain that next time. Because when you were presenting this figure, the only impression I got is you say these two figures gave the same message. But what was that message? It's not very clear. So you have to, and then when you were presenting these two figures, it was really fast. So it's difficult to get your key message here. And so I would suggest here you present this one with a map, and next you enlarge this one, and then tell us again what's the key message here. And then here, I appreciate that you added the supporting figure to make your discussion more concrete. However, you can see that you have a lot of text here, and you were reading through this text very rapidly. So it's again very difficult to understand. For example, here let's say you have this longshore current and you explain it. However, you still again have this micro-tidal regime. What's that? So considering you have enough time, I would suggest that you should, maybe you can split the 4 points each into 4 slides, and each slide you make your figure really big, not distorted, and explain it well. Lastly, here is like you are answering the key question. But I would say, on top of that, maybe you can add a few short sentences as a conclusion slide. As I said, conclusion should be specific. It has to be related to the main finding of the study. It should not be something very general that you can reasonably imagine without listening to your talk. So it has to be very specific. Okay, but I think it's a very well explained talk. Let's thank Barrett.